So if we go through all of these things these formulas, this is why algebra is nice, is that formulas are all meant to make life easier, right? So here, this goofy symbol is you add up all the sides. So the parallelogram is like a regular, it's like a rectangle that's off to the side, so they're all parallel, so that's why it's called parallelogram, but they're not 90-degree angles. So rectangle, these all need to be at 90-degree angles. Same thing with a square, they all have to be at 90-degree angles. A rhombus, they need to be parallel, but not, so a rhombus is a parallelogram with equal sides. So anyways, so a rhombus, you can always find the area of a rhombus if you go the diagonals times each other divided by 2. The parallelogram, straightforward, the height times the base, which is just like the rectangle. It's just that it was crooked, so you can't you can't use the diagonals distance. Base times height divided by 2 is a triangle. Finding the perimeter of all these, pretty straightforward. Just adding up sides, all the outside sides, easy enough. With a square, it's side times itself, so you can do side squared. There you have, so base times height. You can call it width times, so 2 widths plus 2 lengths equal the perimeter. You can go width times length equals the area. Trapezoids are a little different, where it's like a little house kind of thing, a little roof here, and so it would be the little base plus the big base times the height divided by 2, because then it's going to take off this little extra piece here. That's why you divide by 2. So pretty straightforward. These are the two-dimensional shapes, right? 2D like area. Again, you got the pentagon, hexagon, all these regular polygons. So you got your apothem or your height, and then you're making little triangles, right? We just went over that. I went over that last time in the little video there. So the side length. So the side length is our little b here, right? Times the number of sides, times the apothem, and then so you're trying to find the area of a triangle times however many triangles there are. Same thing with circles. Circles are important. Because there's a maximum of 360 degrees in the circle, then it turns into 3.14 is our magical pi number. So well, it keeps going on, 3.14, 16, 17, whatever, times the radius squared, and then the diameter. There's really not that many things to remember with circumference and area. The other piece of our missing formulas is that if you have an arc, then it's part of the circumference, and then this is all part of 360 degrees, and then you got a central angle. Same thing with the sector area is part of the total area. I guess I should write circumference. So it's part of the whole, and these things are all proportional to each other. Like a half is proportional to 2/4. It might be different numbers, but they represent the same thing. They're part of the whole. The same thing as 0.5, that kind of thing, right? If you divide the top by the bottom, 0.5 is the exact same thing as 5 over 10, which is probably what I should have said instead. Alright, this is making sense, I hope. Alright.